before I finish the circuit, one thing I wanted to show you is I'm going to take my multimeter. We've got two 1.5 volt batteries wired in series. And what does that mean? That means the voltages will add. So I'm taking the test leads of my voltmeter or multimeter, and I'll show you this. And we're going to measure the DC voltage. So here I'm using my multimeter. I've got the two test leads. And so here are my test leads, and I've got the alligator clip, so you see a lot of extra wire, but we're reading a little more than 3 volts, which is exactly what we should. Okay, the circuit we are building, or putting together here, is the one that you see in the activity in the book. And I need my switch. So we need to wire all this together, and I'm going to use the alligator clips. So I've got a black alligator clip going to the negative lead of one battery. Connect that to one side of my switch. Then I need to take another alligator clip. To connect to one side of my electromagnet or my nail with my number wire turns on it. And I need one more alligator clip to go from the opposite side of the nail to my switch. So how is this all wired together? Well, is it a series or parallel path is the question. And everything is wired in series. There's no branches. Now, so I've got this wire wrapped around the nail. And once we close this path, we're going to have current flowing through this series wired circuit. And a magnetic field will be generated because we've got current flowing through a wire, and then the nail helps concentrate it at the end. So how we know if it's working? Well, if we have that magnetic field, we should be able to pick up some metal items. In this case, paper clips. So I will close the circuit, and we're able to pick up a nail. We're able to use the nail to pick up a paper clip. How many can we pick up? Well, let's see. And so that's what you would do. So you can see now I've got a closed circuit now because my switch is closed. If I open it, the current is no longer flowing through the circuit, and so my electromagnet is turned off. And we can turn it back on. And so you should get the idea now. And what is the advantage of doing this or having an electromagnet? Well, I can turn it on and off, pretty simple. But the other thing I wanted to illustrate is we're using this cardboard switch. I'm going to take it out. I've got here just a simple toggle switch, and you can see it's actually labeled on off. And I'm going to connect my leads. So the cardboard switch is doing exactly what this does. It simply makes a contact between these two poles, is what we call them. And it's just a simple, it's a single pole, single throw switch. And we can turn it on. So I just simply change the toggle switch to the on setting, move it. And now I have another way to turn this on, this circuit on and off using a conventional switch. And what happens when we toggle it off? We're going to lose that magnetic field. Okay, so I certainly wanted to illustrate that. That you could incorporate any kind of simple switch you may have around the house. Instead, you certainly use your cardboard switch, but if you've got a typical switch you see on the wall, if you have one around the home that you could use, you could try this too. The last thing I wanted to illustrate with the voltmeter again, or our multimeter, is just a continuity on this switch, just open and closing that single contact. And so I'm going to put alligator clips on my test lead for my multimeter. Hopefully you have access to one you can follow along and do this. This gives you another example of how to use a multimeter. And what I'd like to do is, let's say the switch was not labeled and I didn't know which position was on or off. Well, you could put it in a circuit and figure it out, or you could use your multimeter. It's the simplest thing to do. And I've got it now on, I'm checking for continuity, which is what I did this for you in another activity. And you get an audible indicator when the switch is closed. So in the on position, off position. So that's another example of using your multimeter to check for continuity. So what they'll have you do is you'll vary the number of turns on this wire. Number of turns of wire on the nail. And it looks like they range it. They have 4 treatments, so to speak, or 4 experiments. You've got 10 turns, 20 turns, 30, and 50. Now I've got 25, and you can see it may be a little hard to get 50, so you may need to go to a larger size nail. Of course, you could use as an experiment itself. You could keep the number of turns constant and vary the nail size. And what are you using to quantify? Well, and what you're counting is how many paper clips can you pick up